We thought we had this one figured out. 3I Atlas came from outside our solar system, swept past the sun, and kept going. A comet. Case closed. Except it is not closed at all, because the longer scientists study the data they collected during its visit, the stranger this object gets. The water inside it should not exist in the form we found it. The methane it released should not have survived where it was hiding. Its trajectory carries statistical odds that keep making even careful astronomers uncomfortable. And the chemical fingerprints buried in its gas, now being decoded by some of the most powerful telescopes on Earth and in space, are pointing to a birthplace so cold, so ancient, and so completely unlike our own solar system that scientists are now saying plainly that this object belongs to a different chapter of the universe's history entirely. 3, Atlas just got stranger, and we need to talk about every single piece of it. Let's start with the water, because water sounds simple. 2 hydrogen atoms bonded to 1 oxygen atom, something every child learns in school. But there is more than one kind of hydrogen. The common kind, the kind sitting in your glass right now, is just a single proton. But there is a heavier version called deuterium, carrying a proton and a neutron together. Water built with deuterium instead of ordinary hydrogen is called heavy water, and the ratio of deuterium to regular hydrogen in any body of water acts like a chemical thermometer. It records exactly how cold the environment was when that water first froze into ice, billions of years ago. Colder environments lock in far more deuterium. So, measuring that ratio in a comet's water is essentially measuring the temperature of the exact region of space where that comet was born. This is where 3I Atlas breaks everything we expected. A team led by doctoral student Luis Salazar Menzano at the University of Michigan used the Atacama Large Millimeter Array, one of the most sensitive radio telescope networks on Earth, to measure the deuterium content in the water pouring off 3I Atlas as it crossed our solar system. Their findings, published in Nature Astronomy in April of 2026, stopped the entire field cold. The deuterium to hydrogen ratio in 3I Atlas's water came out more than 40 times higher than the value found in Earth's oceans, and more than 30 times higher than any comet ever measured in our own solar system. The lead author put it plainly in a statement to CNN: more than 40 times the value in Earth's oceans, more than 30 times the value in solar system comets. That is not a small deviation sitting at the edge of the normal range. That is a measurement that falls completely, entirely outside anything we have ever recorded. The water inside 3I Atlas formed somewhere so unimaginably cold that even our solar system's most frigid corners cannot begin to explain it. The research team's conclusion was direct. Wherever 3I Atlas was born, it formed in an environment dramatically colder and with far less radiation than the region of space that gave birth to our own solar system. The physical process that built our planets, our comets, our asteroids, simply does not apply here. This object is not just from another star. It is from a fundamentally different kind of place, at a fundamentally different moment in the galaxy's own history. That last point matters enormously, because a second major study, published separately in Nature Astronomy in July of 2026, approached the exact same question from a completely different angle. Astronomers led by Serial Apatam at the University of Edinburgh used the European Southern Observatory's Very Large Telescope in Chile to measure the isotopic ratios of carbon and nitrogen inside 3I Atlas's coma. Different elements, different instruments, different physical measurements entirely, and they found the exact same alarm going off from a completely different direction. The carbon isotopic ratio came out at roughly 147. The nitrogen isotopic ratio came out at roughly 343. Solar system comets typically sit around 90 for carbon and somewhere between 130 and 170 for nitrogen. The VLT's numbers for 3I Atlas sit completely outside the range of every comet ever formed in our own solar system. According to the researchers, those values are consistent with formation in a metal-poor cold environment inside an earlier, less chemically enriched Milky Way. Let that sit for a moment. Metal poor means the star this comet formed around was born when the universe itself was still young, before generations of massive stars had lived, died, and exploded as supernovae, seeding the galaxy with heavier elements like carbon, nitrogen, oxygen, and iron. Over billions of years, the Milky Way has steadily grown richer in these elements as more and more stars have completed that life cycle. Stars that formed early, when the galaxy was still metal poor, built their planetary systems and their comets out of material that had not yet been enriched. Their icy bodies would carry the chemical signature of that ancient, unprocessed environment forever. The carbon and nitrogen ratios in 3I, Atlas, point to precisely that kind of birthplace. A comet built around a star that itself formed when the Milky Way was young and raw. The researchers describe this as a genuinely exciting opportunity to directly probe the composition of another planetary system, one that existed long before our own sun or solar system had even begun to form. Our sun is roughly 4.6 billion years old. The estimated age of 3I, Atlas, based on both its velocity and now its chemistry, sits somewhere between 10 and 12 billion years. That means the ice inside this object, the water, the carbon compounds, the methane our telescopes are analyzing right now, crystallized more than twice as long ago as Earth has even existed. Before our solar system had taken its first breath, 3I, Atlas was already ancient. Now let's talk about what the James Webb Space Telescope found when it turned its mid-infrared instruments toward this object. After 3I, Atlas passed perihelion in late October of 2025, Webb pointed its MIRI instrument at the retreating comet on December 15th, December 16th, and December 27th of that year, while it sat somewhere between 205 and 236 million miles from the sun. The results, published in the Astrophysical Journal Letters in June of 2026 by a team led by Martin Cordner at Caltech, produced the first mid-infrared chemical fingerprint ever recorded of any interstellar object in human history. The measurements confirmed water vapor, carbon dioxide, and carbon monoxide, all expected. But then came the headline result: methane. For the first time ever, methane gas was directly detected pouring off an interstellar visitor. That methane was not sitting near the surface. If it had been anywhere near the outer layers, billions of years of cosmic radiation during its journey through interstellar space would have destroyed it long ago. Methane is extremely volatile, turning from ice straight to gas at temperatures far colder than water ever needs. Its presence in the outgassing after perihelion means it had been buried, sealed beneath layers of protective material, shielded from the sun's heat, until the comet finally passed close enough for that warmth to reach the deeper, icy layers and release methane that had been locked away, potentially, for billions of years. This is a comet with methane hidden inside it like a chemical vault, sealed for most of the history of the universe, finally cracked open by our own sun as 3I at last passed through our neighborhood. The methane production rates Webb measured were extraordinary too, sitting at roughly 14 and then 27% of the water production rate across two separate observation windows. Ratios almost never seen in solar system comets. Earlier perihelion Webb observations had already shown an unusually high ratio of carbon dioxide to water, with carbon dioxide carrying roughly 87% of the object's total gas phase mass loss, itself already far above anything typical. And now, after perihelion, methane was emerging from the depths at levels nobody had documented before. The full chemical portrait of 3I Atlas is one of something genuinely alien, not in the science fiction sense, but in the precise scientific meaning of the word: foreign, built from different material, in different ratios, under different conditions, from an entirely different era of cosmic time. The water is too heavy. The carbon is too heavy. The nitrogen is too heavy. The methane was buried far too deep. Every single piece of this object's chemistry points in the same direction: older, colder, and less chemically enriched than anything found anywhere in our own solar system. If this level of scientific strangeness is exactly why you watch content like this, hit that like button right now, because we still have to talk about its trajectory, and that part gets even harder to explain away. Harvard astrophysicist Dr. Avi Loeb has cataloged what he describes as 22 separate anomalies in 3I, Atlas's behavior, trajectory, and physical properties. He has written about them extensively. And while the overwhelming scientific consensus, including NASA's own official position, holds that 3I, Atlas is a natural comet, the specific data points Loeb highlights are real measurements, not invented ones, even where the interpretation of those numbers differs sharply. The object's retrograde trajectory sits aligned to within 5 degrees of the ecliptic plane, the flat disk in which all 8 planets of our solar system orbit the Sun. The Milky Way's own disk is tilted roughly 60 degrees relative to that plane. If you picked a completely random direction in space for an interstellar object to arrive from, the odds of it landing within 5 degrees of our ecliptic are roughly 1 in 500. 3I, Atlas, arrived from one of the very few directions that would thread it through our planetary neighborhood as neatly as physically possible. Then there is the non-gravitational acceleration, the extra kick of speed 3I, Atlas, picked up beyond what the Sun's gravity alone could explain, which is expected for any comet venting jets of gas. But the jets observed here were described as tightly collimated, meaning focused and directed rather than scattered in every direction, the way a simple, irregular, icy body sublimating naturally would behave. High-resolution Hubble images revealed not 1 or 2 jets, but what appeared to be 3 symmetrically spaced mini-jets alongside a broader coma. Those jets held their orientation across roughly 1 million kilometers in multiple directions. Despite the nucleus's own measured rotation, natural comet jets typically wobble and shift as an uneven surface rotates through changing angles of sunlight. These stayed unusually, almost suspiciously stable. And then there is the Jupiter flyby. When scientists calculated where 3I Atlas would pass Jupiter on March 16, 2026, factoring in all of its observed non-gravitational acceleration, the forecasted minimum distance came out to 53.6 million kilometers. Jupiter's hill radius, the exact distance at which Jupiter's own gravity overtakes the Sun's tidal pull and can hold an object in orbit, was calculated at 53.5 million kilometers on that same date. The two numbers matched within a margin of just 60,000 kilometers, tiny compared to the scale of the distances involved. Loeb calculated the odds of a random object passing Jupiter this precisely at its own hill radius by pure coincidence at roughly 1 in 25,000. Loeb is a serious scientist at Harvard, though his willingness to raise these possibilities publicly has made him a controversial figure in the field. Most astronomers do not share his interpretation, pointing out that apparent coincidences accumulate naturally across enough data points, and that a fully natural comet can still explain every property without requiring new physics. The SETI Institute and Breakthrough Listen sifted through nearly 74 million radio signals from the Allen Telescope Array. 201 candidates survived filtering, every single one traced back to human or satellite interference. No alien transmitter was detected at any power level in any frequency range searched. NASA's official position remains unchanged. 3I Atlas is a comet. But here is why this conversation still matters. The anomalies Loeb points to are not invented. The retrograde trajectory aligned within 5 degrees of the ecliptic is a real measurement. The collimated jets sit right there in the Hubble data. The Jupiter flyby distance comes straight from the orbital calculations. And the chemistry is genuinely off every chart we have. The water is 30 to 40 times heavier in deuterium than anything ever measured before. The methane survived, buried deep enough to outlast billions of years of cosmic radiation. The carbon and nitrogen ratios sit entirely outside the range of every solar system comet ever studied. If 3I, Atlas, is natural, and the scientific consensus firmly says it is, then what we encountered here is something that proves the universe is far more varied in both chemistry and history than our own solar system could ever reveal on its own. We have studied comets from our own neighborhood for centuries, comets that all formed in the same general region of space, around the same star, in the same era. 3I, Atlas formed somewhere else entirely, around a star that existed before our sun was even born, in a colder, older, chemically different corner of a galaxy that was still young. And when it released its ancient ice, as it swept past our sun? It handed us a direct chemical sample from a world we could never physically reach, from a time we could never visit in person. The Subaru telescope in Hawaii observed 3I Atlas on January 7, 2026, as it emerged from behind the sun after perihelion, focusing on the interior composition finally exposed by that heating. The carbon dioxide to water ratio measured there was lower than earlier pre-perihelion observations had shown, and that difference told scientists something important. The outer and interior layers of 3I, ATLAS, carried genuinely different chemical compositions. The outer surface, baked by billions of years of cosmic radiation, had already been measured. What emerged after perihelion came from deep inside, from a pristine core sealed away from radiation for most of the history of the universe. And even that interior turned out to be chemically unlike anything in our own solar system. By March of 2026, the object had passed Jupiter and was heading outward. As of August 2026, it has already crossed beyond Saturn's orbit, receding at 60 kilometers per second, a speed nothing humanity has built could match. It will not return, it is gone. But what it left behind is a data set unlike anything else in the history of astronomy. Hubble, James Webb, the Subaru telescope, the Very Large Telescope, the Atacama Array, even the Europa Clipper spacecraft, all collected pieces of a puzzle scientists are still assembling right now. What is already clear has already changed planetary science permanently. What 3I Atlas has shown us in the most direct and physical way possible is that our solar system is not typical. The conditions that formed our sun, our planets, our comets, our oceans, are not the universal template for how planetary systems come together. Somewhere out there, around an old and metal-poor star that may not even exist anymore, a planetary system formed under conditions so cold that its water ice locked in deuterium at 30 to 40 times the concentration found in any comet we have ever measured. Carbon and nitrogen settled into isotopic ratios entirely outside our known range. Methane accumulated in deep interior layers and stayed there frozen and preserved for 10 to 12 billion years, long enough for our entire solar system to form, evolve, produce life, produce intelligence, build telescopes, and finally catch one small frozen messenger drifting through our neighborhood on its way to somewhere else. If this is the kind of story that genuinely reshapes how you see our own solar system, subscribe to this channel and turn on notifications right now, because more interstellar visitors are coming, and I want you here the moment we catch the next one. We have now detected 3 interstellar objects passing through our solar system. Oumuamua in 2017 barely caught, its true nature still genuinely debated. Borisov in 2019, which behaved far more like a familiar comet, but still came from somewhere else entirely. And 3I Atlas in 2025, the brightest, the most chemically detailed, and by far the strangest of the 3. Each one told a different story about what exists out there, and each one we only caught because our instruments had become just barely sensitive enough to notice in time. The Vera Rubin Observatory in Chile began issuing real-time sky alerts in February of 2026. Its 3.2 gigapixel camera, the largest digital imaging device ever built for astronomy, scans the entire southern sky every 40 seconds. Researchers now expect the discovery rate of interstellar objects to increase dramatically, moving from catching one every few years to potentially catching several every single year. Each one, another chemical sample pulled from another ancient corner of the galaxy. 3I Atlas did not just pass through, it rewrote what we thought we understood about how different the wider universe can be from our own backyard. Its water was unlike any water ever measured. Its methane was buried in layers sealed shut before Earth even existed. Its chemistry was forged in a galaxy younger and colder than the one our own sun was ever born into. And the anomalies in its trajectory, aligned too neatly, aimed too precisely, threading Jupiter's hill radius closer than comfort allows, will be debated by serious scientists for years to come. Not because most of them believe it was anything other than a natural comet, but because every single one of those data points is real, every measurement checks out, and the universe, exactly as 3I Atlas just reminded us, still contains things we genuinely did not expect to find. Think about what it even means that we are having this conversation at all. For nearly all of human history, the idea that anything could travel between star systems was pure theory. Stars sit separated by distances so vast, the concept barely fits inside human imagination. Proxima Centauri, our nearest stellar neighbor, sits about 4.2 light years away, and even our fastest spacecraft would need tens of thousands of years just to reach it. The idea that a comet could form around one star, get gravitationally ejected from its home system, drift across interstellar space for billions of years, and then pass directly through our solar system at the exact moment we happen to have telescopes sensitive enough to catch it, sounds almost impossible. And yet, it has happened 3 times in 8 years. The reason we are seeing this now is not that interstellar objects are new. They have been drifting through our solar system for billions of years. We simply never had instruments sharp enough, sky surveys broad enough, or alert systems fast enough to catch them in time. The Atlas Sky Survey, which first spotted 3I, Atlas on July 1st, 2025, was actually designed to catch fast-moving, suddenly appearing objects for planetary defense, built to protect Earth from asteroid impacts. Instead, it found an ambassador from another star system entirely. What changed is our vision. We finally built sharper eyes, and the moment we did, the first things we saw were things nobody had ever seen before. Not because they were never there, but because we simply could not see them until now. Before you go, tell me in the comments below which single fact about 3I, Atlas actually stopped you cold: the impossibly heavy water, the buried methane vault, or the eerie precision of its Jupiter flyby. And if this story genuinely changed how you think about our place in the galaxy, share it with someone who needs to hear it. It takes 10 seconds, and it is exactly how a story this strange finds the people who will appreciate it most. 3I, Atlas is gone now, racing outward at 60 kilometers per second, carrying the rest of its ancient secrets with it into the dark. But it left behind proof, undeniable and permanent, that our solar system is only one small chapter in a much larger, much older, much stranger galactic story. And somewhere out there, the Vera Rubin Observatory is already scanning the sky for Chapter 4.